So here we have two different equations. We have 8x plus 4y equals 12 and 12x minus 1 half y equals 5. You should recognize these equations as equations that are in standard form from back last week when we were graphing. But there are also times when we come up to equations that are set in this type of formation where these equations actually are dependent on each other, and we need both of these equations to actually figure out what's going on. And when we find that, that's called a system. As you can see, we have these two variables, and in order to find both of our answers to figure out what x and y are, we need both of these equations. Okay, so there are a few different ways that we can solve systems where we have these equations that have two different variables. Today we are going to focus on a method that you worked on last week, and we're actually just going to be graphing these. Okay, so just like we did last week when we were working with standard form equations, we're going to solve these for y in terms of x, meaning that we're going to get the y all by itself on one side, and the x is going to be inside a term on the other side of the equal sign, and then we're going to graph them. And at some point, these graphs are going to intersect, and that is the coordinate solution for these equations. Okay, so let's start with our 8x plus 4y equals 12. So what we're going to do, again, to get that y by itself, we're going to subtract our 8x. Subtract our 8x. We've got 4y equals negative 8x plus 12, just to keep it a little bit more consistent for when we graph it. Now we're going to divide everything by 4. We get y equals negative 2x plus 3. Okay, that's a pretty standard slope-intercept equation. Should be pretty easy to graph it. Okay, now let's look at this 2x minus 1 half y plus or equals 5. So again, we're going to solve it for y, getting y all by itself on one side. So we subtract the 2x, subtract the 2x. We're left with negative 1 half y equals negative 2x plus 5. Now we have this negative 1 half that we need to deal with. Okay, so 1 half, taking 1 half of y is the same as dividing y, right? So we need to multiply by 2 to get rid of the 1 half, and then we need to multiply by a negative 2 to get rid of that negative with the y. Okay, so we multiply everything by that, we get y over here. We get 4x minus 10. All right, so those are our equations. Now we're going to come down here and let me just bring this up a little bit. Okay, so negative 2x plus 3. So we come up here. Go away, I would like to count. 1, 2, 3. Down 2 over 1, down 2 over 1, over 1, and there are. We grab something nice and straight, draw our line. Now there is always the danger in this method that, sorry about that, that your system is not going to be solved in this line. Our blue line over there, it could cross somewhere over here or something like that. So that is a danger. Okay, but let's go ahead and check. So we start with negative 10, which is going to be here-ish. We'll go with that. We count up 9, 8, 7, 6. So that's 4 and 1. 1, 2, 3, 4, and 1. Grab our straight line. And sorry about that. It's happening from the thing that I have to draw my straight line. Okay, so we have our intersection or our solution roughly right here, which isn't at an exact intersection. It's not at, the point 4, 6 or something like that, but we can see this is where those intersect. Now let's talk about how these equations relate to each other and why on earth we would do something like this. All right, so here we have a situation. Cheddar cheese and mozzarella cheese cost different amounts per kilogram, but you do not know how much. A box containing 3 kilograms of cheddar cheese and 2 kilograms of mozzarella cheese costs $29.95. Another box containing 4 kilograms of cheddar cheese and 5 kilograms of mozzarella costs $45.65. Assuming that these figures are for the cheese only, how much is each kind of cheese worth per kilogram? So we could solve this one by graphing. Given those numbers, it's probably not going to show up on our graph. So we're going to save the actual solving of this system for another day when we get some other methods. But what I want you to work on, you're going to have some story problems like this in your assignment. I want you just to set up your equations, okay? Just get your equation set up, get your system set up, and then solved for y. Okay, or whatever your variable is. Solve it for one of your variable. Here today I'm going to use the variables c and m because that's what we have. So we have two situations. We have 3 kilograms of cheddar, 2 kilograms of mozzarella, and it's $29.95. Okay, so we have an amount of cheddar plus an amount of mozzarella equals $29.95. We know that the prices are per kilogram. Per kilogram means there's a certain amount that is multiplied by every kilogram. So the 3 kilograms, that is going to be our direct coefficient. And then our 2 kilograms, again, is going to be our direct coefficient. So that's our first equation. We also have this other situation down here of 4 kilograms of cheddar, 5 kilograms of mozzarella, and $45.65. And we're going to set it up exactly the same way. So now we have 4 kilograms of cheddar plus 5 kilograms of mozzarella equals $45.65. So that's how you're going to be working through the story problems, just to set them up, and then again from here solve them for one of the variables. We've been solving for the second variable. If this was standard form, this would be the y column. But if you want to solve them for c, that's fine too. It really, in our future methods, it doesn't matter so much which variable you solve for. It only matters that you solve for y if you're going to be graphing.